And it's showtime. Welcome everyone to the first meetup of 2024 of Tech Excellence. We are super excited for this year. We have many cool things planned, so stay tuned. Our vision is to raise the bar of technical excellence across the world. Here are our organizers. First and foremost, Valentina Cupac, our founder and organizer. Next to her, we have Alina Liburkina, co-organizer. Next to her, we have Oliver Ziller, another co-organizer. And last but not least, me. Yeah, here are our speakers for this year. It's not the full year, but for the next weeks, you see, we have a really great session planned. So stay with us. And yeah, we are online and we can be found in a lot of places. First of all, we have a website, techexcellence.io, and you can follow us on Meetup, YouTube, LinkedIn, Twitter, or X, GitHub, and we have a Discord group as well. Feel free to join to us if you have any questions about Tech Excellence. Yeah, big thanks to our sponsor, Optivem, and to our partner, QE Unit. Learn how to deliver quality software faster. All right, so the speaker of today is Alex Stücker. Let me introduce him. He is deeply passionate about learning and advocating best software engineering practices such as domain-driven design, test-driven development, and other practices of XRAM programming. He works as a software architect for Digitech Galaxus AG in Switzerland. And the topic of today will be DDD, deep dive into aggregates. And before I hand over the microphone, I would like to remind you that at the end of his session, we're going to do a Q&A. So if you have any questions during the session, do not hesitate to ask it in the YouTube comment section. And at the end, we will go through all the questions and Alex will answer. So Alex, first of all, welcome. We are very glad to have you. And
Thank you very much.
The microphone is yours. I wish you good luck. And enjoy.
Thank you. Thanks for having me. It's a pleasure to be here. Okay, let's see. Our presentation today, the talk will be about deep dive into aggregates, DDD aggregates. And without further ado, let's start with the presentation. Let's see what we will cover in this talk. The agenda for today will be, we will start today with the building blocks of an aggregate. We will see what the building blocks of an aggregate are. Then we will try to ask some questions like how are aggregates defined? Why do we have aggregates? Are aggregates in general and DDD aggregates the same? Are there any differences? Then next we will see the effective aggregates are defined and shaped by their behavior. We will see and discuss why behavior is important and some potential challenges and pitfalls when we are designing aggregates. And at the end, we will have a question and answer session. Yeah, that's all. And that will be the presentation, the agenda for today. In this presentation, I will try to, I hope, to provide some food for thoughts. I will focus more on ideas and concepts, maybe show some code, but the focus won't be coding. Now, let's start with the first building block of an aggregate, entities. And what is an entity? An entity represents an individual thing. And this thing represents a concept or something in our domain. Then entities are characterized by having a unique identity. The identity must not be just something technical like a DB ID or something. There are also natural keys, domain keys, identifiers. This can be something like social security number, ISBN for books, or a national identification number, passport number, SWIFT number. These are all identifiers that can be used in the domain. Then entities have a life cycle. The entities are created, they are stored, persisted, reconstituted, modified, and they can be deleted. Another attribute of an entity is they are typically mutable. They change over time. An example can be a person. A person has an age, weight, or height that will change over time. As we got older, we will be less high or we will age. Another one can be a car where the color can change or the mileage can also change over time. Then another property is entity encapsulates both state and behavior relevant to the domain. Okay, that's not just for entities. The next building block will have the same property. And these are the properties, or that is what defines an aggregate. Now let's see some example of entities illustrated. An example of an entity could be a customer. A customer has an ID, a name, an address, a phone, or an email. And as mentioned before, the address could change, the phone number can change, but the customer will always be the same. And there's where the identifier, in this case, the customer ID, is so important. Another example of an aggregate can be a product. It's the same, product ID, always an identifier, then some properties that describes the entity. In this case, name, description, category, price, stock quantity, and more. Another example of entity can be a bank account. The same account number would be the identifier, and then other properties that can change over time. Supplier would be an entity, an employee, or a real estate property. Now, the next building block that we have when we are talking about aggregates are value objects. And they have also properties, and one of the properties that a value object has is that a value object models an immutable conceptual whole. Normally, a value object is completely replaceable when the measurement or description changes. It is immutable. Then a value object does not have a unique identity. That's the main difference to an entity. So if they don't have an entity, how is equivalence determined? And equivalence is determined by comparing their attributes. This means value objects, they have value semantic and therefore structural equality. If this means if all attributes match, then it is the same value object. Another property is value objects are interchangeable when their attributes match. As mentioned before, if there are the same attributes, then it's the same object. As I have mentioned already, it has value semantic and it's like an int. An int with the same value, it's the same int or the same decimal. Then value objects are used to quantify or describe things in a domain. This is important because value objects will help us increase cohesion and makes our code more explicit. We probably will see some examples of that. And then value objects can be shared across different parts of the domain model. And one of the reasons that they can be shared is thanks to immutability. This means there are no risk to introduce some side effects. So these are the properties that have a value object. Now, let's see some example of value objects. In this example that I will show, we will see a lot of primitive obsession, but don't worry, it's just the purpose of the presentation that I'm doing this. And one of the first examples is money, like a value object. A money has maybe two values, an amount and the currency. And if we have two monies, or let's say it with the money, if we have two money objects or value objects, and they have the same amount and the same currency, then it's for us the same value object, and we can interchange them, and it doesn't matter for us. Another example will be a color, where we have red, green, int, also red, green, blue for a color. That's the RGB, where we can, when we implement it, say, okay, the values of the int can be limited from 1, 0 to 255. Then we have an address. An address can be another value object with 4 properties: street, city, postal code, and country. Another can be contact information with an email and a phone, or a file size where there's a value and the unit, or some nutritional information, carbs, protein, fat, and then the calories. Or geocoordinates, latitude and longitude, or some date range where we have a start time and then the end time. And something that I personally find really cool from value object is we can ensure that when a value object is created, they are valid, and rules like, as example here, the date range, that the start date is always before the end date and not the other way. And so once we have a date range created inside our code, we know this constraints or this rule is respected. Now, let's recap and see what are the major differences between entities and aggregates. Again, one of the first differences is entities have identifier equality, aggregates have structural equality. Then entities have an identity, value objects don't have any identity. Entities are most times mutable because they change over time, can change over time, and value objects, they are always immutable. Entities have a life cycle, value objects do not have a distinct life cycle. And entities are not safely interchangeable, where value objects, they are safely interchangeable. And that's, again, because of the immutability. It's like let's say a person Tom is, if we change Tom with another person with the same attributes, then it's not the same Tom, it's another person. If we take a value object, let's say $20, if we change it with another $20, for us, it's still the same. It's still $20. Then let's see how a value object or an entity could look like in code. Let's switch to right a moment and take a look at some value object. Now, if we are in C#, there are multiple ways how we can implement a value object. One can be that we maybe implement it like the color code, where we have a class, we declare a class, it's color code with a constructor. The constructor makes sure that the color code here is hex format is correct. And if it's not correct, it throws an exception in this case. And if it's okay, then the value object is generated. Now, important here is, as we have said in the presentation, a value object, always the attributes are compared. And that's here the same. Then it's really important to override the equals in order that both that the code or all properties are compared. And so the get hash code function. Another way to implement a value object is maybe using something that is newer, and that is records. A record is immutable, and they have already, when we compare them, they already are a structural equality. We have less code, and that's also a way to implement a value object with a record. Now, the important part, if we have any validation or something that it's enforced in the constructor or using a factory method, is that we remove the inits. If we let in the inits and the constraints or the rules, the invariants are only checked in the constructor, if I'm not wrong, it won't be checked again. Then there's the possibility to, with the with keyword, generate an invalid money object. But if we remove the inits, then it will be immutable, and only the constructor takes care that it will only create it if it's valid. And another possibility is to create one, the class Microsoft. I have copied the class. A lot of people that I know use this, have a base class, an abstract class, where the operators are overridden, and then we have less code. We can use a class, say that it inherits from the value object, and then we just need to provide the get equality components. Here I missed one. I've said all properties must match. This means calories is also a property. It means calories should also match, so that it matches the definition of a value object. If these properties are guaranteed, then we are talking about a value object. If we make it mutable, then it isn't a value object, in my opinion. Now, I have written here some test where I take two value objects and then assert that they are equal using the equals and the overloaded equality operator, and then make sure that it's not the same reference. And I've made it for all three implementation, and what I expect is that the test says that it's the same object. Let's wait. As you can see, everything is green. Then let's see entity. Here I have an small implementation of a product entity. Here the same, a little bit of a primitive obsession. We have created a product with a product ID, name, string, a price. We are using money, a value object that we already seen before, and an int, a stock quantity. And here it's the same. I have just chosen some checks to ensure that the name or the description isn't empty, and the stock quantity it's not negative. And then we initialize the product. At the moment, I do not have any methods to modify it, but it's possible. Entity can be modified. Then if it's required, no problem to use a private setter or something like that. And then it's the same. An entity is equal if the identifier is the same. And then it's important so that this class behaves like a DDD entity is to override the equals and compare the product IDs. And also override the hash code. Also overloaded the operators. And here I have the same test. I create two products with the same ID, but different prices. The second one is a little bit cheaper, and we have less products in stock. And then we make the same, we compare it, and it should say it's the same product. This one was fast. Here, the test is positive. This means the code says it's the same object because it has the same ID. So let's go back to the presentation. Now, sometimes when I'm talking with other engineers or developers, there are sometimes a little bit mistake. Sometimes they say to value objects that these are value types, and there's a difference between value objects and .NET value types. And I would like to go over it with you. And one of the differences is value objects is something conceptual. It's in DDD is something that is domain specific, whereas value objects is something technical, depends on the programming language. Value objects are always immutable. .NET value types are not always immutable. A good example of it could be a struct. These are value types, but they aren't immutable. Then both have structural equality. A value object can be complex, whereas .NET value types are generally simple data structures. And these are some of the main differences between value objects and value types. Those concepts are not the same. Now, let's go to the next point, and let's start with the aggregates. What are aggregates? An aggregate models a conceptual whole of the domain. An aggregate is a cluster of domain objects. Till now, what I've said about aggregates matches with the general definition of an aggregate. An aggregate is just a cluster of domain objects. But now, from now on, there will be slightly differences. Each aggregate has a root and a boundary. The root is a single and specific entity contained in the aggregate. Aggregate enforces business rules and invariants. Here's again a difference between the general concept of an aggregate. DDD aggregates really enforces business rules and invariants, and that's important. The next one is an aggregate forms a transactional consistency boundary. This means everything that is modified with the aggregate is persisted with the aggregate. And then another thing that is allowed is outside objects are only allowed to hold reference to the root of the aggregate. And the root entity has a global identity. This is from the book from Eric Evans, Domain-Driven Design, Tackling Complexity in the Heart of Software. That is how he defined aggregates. Something that's important to say, or I forgot to say, is the root, or the entity root is the root entity of an aggregate is called the aggregate root. Then next, let's see what are the aggregate design rule of thumb. These are from von Vernon. And he says, one of the rule of thumb is protect business invariant inside aggregates, boundaries. The other one is design small aggregates. That's sometimes a challenging one, to design the aggregates as small as possible, but as large as required. The next one is reference other aggregates by identity only. And then update other aggregates using eventual consistency. This means do not update multiple aggregates in the same transaction. These are from von Vernon, from his red book, Implementing Domain-Driven Design. Now I would like to get a little bit interactive and switch to Excalidraw and start drawing a little bit. So let's imagine we join a project and they give us the following domain model. There's a domain model that they will give. It's not implemented, but that's the idea that they have. They would like to have they say there's a customer with a customer ID, a name, an email, a phone number, and that address. And they say a customer has at least one address. Then they say a customer can have 0 or multiple orders. An order has an order ID, a customer ID, order date, status, total amount. And the status can be it's new, processing, shipped, or delivered. The order also can contain multiple order items, at least one. And the order item, the same. They say, okay, here is an order item ID, an order ID, a product ID, quantity, unit price, and the total price. Then they have a reference here to say, okay, an order item will always be a product. This means every order item is a product, and the product has the properties product ID, name, description, price, category ID. There's modeled it this way, with a name and a description, a status, an inventory count, and some images. And the product status. The product status can be active or discontinued. And at the end, they say, okay, we have products, and the products that there's possible to add some reviews. And here we have a review ID, product ID, customer ID. You can read it by yourself. And now they gave us this product, and they say, if you look at it, this seems a little bit like an e-commerce system or something similar. And they have a little bit of problems with this model. And they would like that we introduce some DDD concepts to improve it. And now if we look at it, what we can do is be maybe naive and say, okay, it seems like this could be a good, the entire tree here seems like an aggregate. Let's just say this is the aggregate root and the entry point. And say a customer can have an order, then we add an order to the customer with some products. But I think, as you all may see, that's a naive assumption to select this one as the aggregate root. The aggregate here is too large. Now what we can do, this is a large aggregate, and it will be nice to break it down. Large aggregates, this is obviously a very large aggregate, but in real life, sometimes we see large aggregate, maybe not that large, but large aggregates. And that's something, sometimes a pitfall that we see. And one of the consequences that we see this, if you see, we have just see the structure of the model. We don't see any behavior. And that's something that often happens also with small structure, is that we see something in an anemic domain model. There's nowhere some documentation about what is the behavior that we want to provide. And if you don't have any behavior, then usually we are probably we are neglecting some business rules and invariants. And then it's really difficult to identify properly the aggregate. Now, what can we do to improve this? One of the first things that we can do is identify the bounded contexts within our system. For those that don't know, a bounded context is a conceptual boundary within which a particular domain model is defined and applicable. There are some techniques that we can use to find these boundaries, and I will write just them just a moment here down. Let me zoom in. L. And one of them, maybe you know them, is event storming from Alberto Brandolini. I think this is the most popular one. Then we have another techniques to model collaboratively a domain, and this is a event model. This one is from Dimitruk. The third domain modeling technique that I know, there are probably more. So the one that I'm more familiar with is domain storytelling. This one are from Hofer and Henning Schwendner. There are 3 techniques that we can use to find bounded context and to discover what are the behaviors that we need in the system. Now, if we see our model, let's use event storming or try to do some kind of event storming to find out what could be the boundaries. When we talk with these techniques are used with domain experts, and now we are maybe interacting with them, and they will give us some fact or things that happen in our system. And one of the things that can happen, let me put something out, is when we're talking with them, then we say, okay, let's put it in black. They say a customer is using now a lot of events. If there are any people that do not know anything about event storming, I think in this TechExLugs meetup there are some videos where this is done and explained, or in the internet you will also find a lot about it. Then the orange is the color that we use, and then the domain expert says a customer is registered. Something that maybe he'd also say this customer is registered, there says customer added a new address. Another fact that happens, then maybe customer removed address. It also happen, maybe phone number changed. Customer phone number changed. Something happen in the system. We put some more paste. This is e-commerce maybe, or paste. And that's probably the possibility to say order cancelled. Or if you do not cancel the order shipped. Or maybe you change your mind and say, okay, let's deliver it to another address. Then we say delivery address. Delivery address changed. And another domain expert that is responsible for all the product says, yeah, something that happened is new product added. Or we have said something about reviews, maybe product review posted. Inventory, exact inventory. So writing a lot of events down. We will now do something with them. Maybe product. Not. I think we can stop there. Now with thanks event storming or the events, the facts that happened in the system, we can now see what are the capabilities, the features that we need to provide with this domain model. What's the reason that this domain model exists? And now I will jump and not continue really with event storming, but I will now try to find out what could be some potential bounded context. If I see here customer registered, customer added a new address, I'm now messing up the timeline. Then maybe customer removed address, customer changed phone number. This seems something how related. Then we have order placed, order cancelled, maybe order shipped, delivery address changed. This seems to be related to the order. New product added, that's something different. Product discontinued. Product review posted, and maybe inventory adjusted. Let me see if I have all of the events. Yes. Now, if I look at this seems like this events here are somehow related to customer management. Eventually has somehow something to do with managing our customers. Then the next one seems to do with order management. The last one seems to be focused on product management. Inside from every of these boxes are the events that happens. Now we could maybe say we have identified 3 possible contexts: customer management, order management, and product management. Here we are dealing with customers' information and profiles. In the order management, we are focused on the life cycle of the customer orders. And in the product management, we are handling everything related to products. Now let's go back to our first domain model. We'll copy it and put it on the head of it. If I now take a look at our model, I will now take this one. I will say everything that has something somehow to do with customer management seems to be these two tables. I'm now say tables, these two, yeah, let's say them tables. And product management seems to be something down here. Products, new product added, something about review posted. Seems that this tables here has something to do with product management. And then the one that is left are, let's move it a little bit to the right. Is this one. That is order management. Now, if we look at it, we would like to find, now we have found some boundaries, context boundaries. Now it would be nice to find our aggregates. Aggregates live always inside a context or a bounded context. This means here maybe this one could be maybe an aggregate, a customer with the address. Let's put this in green and say, okay, we have identified our first aggregate maybe inside this bounded context. Then we have maybe a second one here, order with order status and an order item. Then let's say, okay, this is maybe an aggregate. And the last one, the product. Just being naive, these are our first 3 aggregates. Now, if I would like to handle these references, that not everything is interconnected. One of the rules when we design aggregates is that we only reference other aggregates by their identifier. Then let's see. If we start here. Here we are inside the aggregate. We say, okay, we have a customer. A customer have 1 or more addresses. Think this is same. This is safe. This connection. We will leave it where it is. Then we'll take a look at the customer and the order. And do we see here we have a reference. Both are aggregates, but we won't connect them now. This way we want really to separate them. And we have it here already. That's the customer ID. We have the customer, and we have here an order that the customer ID, it references another aggregate root, and that's fine, that's okay. And then we have the order item that belongs to the order. That's okay. Then we have here another reference that leaves our context boundary. We'll remove this connection and look at an order item will always have a product, and it references child object inside an aggregate is allowed to reference another aggregate root identity. That's the case, and this is allowed. That's fine. It references another aggregate's root identity, product ID. We have another item, another ID exactly. This means that also okay. And we have here the product. The product can have 0 or no category. That seems a little bit strange. We will come back to this one. And then let's see this one, this connection that is leaving our context. There were a context that we have a review, and we say a review belongs to a product, and it has a reference to a customer, the customer that posted the review, and that's a reference to another aggregate root. That's also fine. Now, it seems, the first impression, that we have really found 3 aggregates. Customer, address. Let's make it a little bit nicer. An order that has an order status. That's probably an enum. And an order item, 1 or more order items. And then we have a product. Now, I will go now from the left to the right through the aggregates. And I would like to see, in the definition of an aggregate, we said an aggregate is a transaction boundary and it protects business rules and invariants. And now let's see if here we have some rules that must be respected, or if we can make smaller, so that maybe we have 2 aggregates instead of 1. Let's just see and make some assumptions. We have a customer, and here we have, I'm interpreting it as like a customer must have at least 1 address. This means that it's some kind of rule. Then more probably it's meaningful. It will be nice when the customer, this entity, ensures that there is always at least 1 address, because I can add and then have 5 and then start removing it, and this entity will ensure that we always have at least 1. This means here probably is some rule, some business rule that says black or blue. We always at least 1 address. Now, if we're modeling it, we have now at least 1 address. We have here in the address, we have selected to put here an address ID, street, city, postal code, and country. This means these 2 are now implemented both as entities. Let me use an E as an entity, and this one is an entity. It's not a value, it has an ID, an identifier. Now, can we maybe speak with the domain experts or with colleagues and find out, in this context, is the address, it is really an entity, or is it maybe a value object? If we have 2 addresses with the same street, city, postal code, and country, are we talking about the same address, or is it a different address? Probably, in this case, maybe they say, okay, if they have the same property, then we are talking about a value object. This means we will try to implement it and design it as a value object. We will remove the address ID. We are here now, we are not designing tables, we are designing code, our aggregates and code, how our classes, records will look like. And we say this one is a value object. We have the same address, same properties, the same address. That's something else that now the customer entity can ensure. If we already have an address that would like to add the same address twice, we know we already have the address. it's not required to add the same address twice. That's something else that can make the customer can ensure is maybe the same address cannot be added twice. So now let's move on. I think that's fine for the moment. Looks good. Now let's go to the next one. The next one, we have an order. And we decided at the moment that the order is the root entity, the aggregate root. And it has a customer ID, that's a reference to another aggregate, that's perfect. An order date, a status, and the total amount. Status, we already saw it. And then we have an order item. Now the order item, here we have the same. This one is an entity. The order item is at the moment also an entity. It has an order item ID. Then it has an order ID. I think here it's because it's not a database table, we can remove it. And say order item, it has an order item ID, a product ID, that's another aggregate, a reference to another aggregate, a quantity, a unit price, and the total price. Now, I always like to ask the same question. Is this really an entity or can it be a value object? I love value object. I'm a fan of immutable stuff. Now, let's see. Something that an entity has is a life cycle. It changes over time. Now the question that I can ask myself is, this order item, can an order item maybe change over time? Is there a possibility that it changes? Probably in this case, in this current model, if we look at the property USA, and probably not, because we didn't have any features or the capabilities that allows us edit our order. This means in this case, maybe we could implement it as a value object, but in reality, is an order item, there's a probability that you maybe just change something on the order item and that it's really an entity, it will change over time. This means in this moment, I will leave it as an entity and argue this is an entity. This means an order is composed from multiple order items, and both are entities. And then I will go to the last one, the product. And if I look at this, I see that we have a product with product ID, name, description, price, category ID, status, inventory count, and images. Now, what's interesting here to see is, if I interpret it here correctly, there's a possibility that a category can exist that is not yet used by a product. And if the category is part of the product, it can't live by its own. This means a category that does not have a parent object entity can't exist. That's another difference. That's one of the reasons, because we will never nest aggregate. Nesting aggregate is something that it's not desired in DDD aggregates when we are doing domain-driven design. And where was I? Yeah, it's like now I know what I wanted to say. An aggregate in domain-driven design is more like a composite. If the product does not exist, the child objects can't exist. They will stop existing as the parent. The aggregate root dies. And this one is the same here. A category should continue living. That's maybe a sign that a category is not a part of the product aggregate. Maybe it would make more sense to implement the category as an own aggregate, a smaller one, and say Let me here just change and add aggregate root and entity. Differentiate the entities that are aggregate roots. Same here. And then now it's safe. We have here a category ID. And this one, this one has a reference to another aggregate root. That's fine. We're not breaking any rules. And the same happens here in the review. If we see a product can have one or more review. Here we can maybe, there should not be a problem. Here we can really say maybe that's an entity inside the product. And this one has a reference, product ID, the parent one, and the customer ID, that's another aggregate root, both are aggregates root, that's fine. Something that I haven't said is inside an aggregate, it is allowed that internal entity IDs are used, that maybe this review has a reference to another ID inside the aggregate. That should not be a problem. The problem is from outside, we should never have a reference to something inside an aggregate. Now, we have maybe discovered it and say, okay, now we have 3 aggregates. Something that I did miss now is to identify, can we make this aggregate smaller? Is it correct? Make it sense this way? And something that is always good to see is, are there some business rules or invariants that must be held? Here we already found something that makes sense because the customer, the aggregate root, will make sure that we always have at least one address and that the same address cannot be added twice. Now let's see in the order. Here I've made something similar. Sure that it does not make sense to have an order without any order items that we have ordered. This is, we always want at least one order item in the address. Rule. Another rule maybe can be the total amount. The total amount equal to the sum. Let's see how I will write this down. Sum of all order items by total price. That's another like business rules that we have. So we don't have, this can be calculated at any time when we have the order. The total amount is always the sum of the total price. And here is maybe another one inside this entity, and that is the total price equal the quantity times the unit price. Maybe a possible way we can do it. And probably we have more. Let's go back to the order manager, to our events. And we have here something like order placed, order cancelled, and delivery address changed. Here we have 2 interesting events that can happen on the order aggregate. And now we can maybe add some business rules and say, okay, when a product, let's see the status, shipped and delivered. I think when an order is shipped and delivered, then it's not possible to cancel it. Maybe meanwhile the order is new, and when we are processing it, it's probably possible to cancel it. Then we can here add a new maybe business rule that says orders are only cancelable if they are new for processing. There's another rule that now our order has to take care of. This means if the request comes that we have to cancel the order. We load the order from the database using a repository, and then say the order held on task principle, say cancel, and the aggregate will check that the status is in a valid status, so that it will allow a cancellation or it will reject the cancellation. Let's see another one, the same with the address changed. Let's here add another one, maybe changes only possible if the order is new for processing. I think these are enough business rules for the moment. It seems like the order aggregate seems to be okay. It can get large if we have 1,000 order items, but let's fix this problem when we get there. Now, let's go next to the product. If we look at the product, we had here some, you know what? Let's move this one here so that I don't have to scroll. What's interesting to see is here we have maybe new product added. When we add a new product, that's not a problem. Then we create these three stuff, or the product with the product status. A product is discontinued. I think that's just possible if it's active. If the product is already discontinued, then it will stay in the same. That's something that maybe this aggregate must handle. Das heißt, this means if the product is already discontinued, nothing happens. And if it's active, then it will change to discontinued. Then product review posted, that's this one, and inventory count adjusted, it's the same. Now, if we look at the inventory count, we will maybe talk again with the domain experts, and they will maybe say, okay, the inventory count will be never negative. That's what they say. We'll make this assumption that this is true. Then maybe here another constraint that can be here is, okay, inventory count should always be greater 0. And maybe we have another ones more. Maybe images that's now not really visualized. Maybe it's at least we need them in the image. Then it's a rule also that we made. Now, just a moment. Perfect. Now we have probably found our aggregates. When we look now, we have now 4 aggregates. We are respecting at the moment all the rules that defines an aggregate. We are only referencing other aggregates, not entities inside. The aggregates are enforcing our business rules or invariants. And they seem not to be that large. They are relatively small if I compare it with the first model that we had here. As you can see, finding the pattern context helped and is important. That's an important part of strategic DDD. And in my opinion, tactical DDD without strategical DDD is worthless, is a big mistake that we can make, because often my experience is we then tend to create wrongly shaped aggregates. Now, let's recap what we have done. We have at the moment a customer where we have some functionality that we are providing. functionalities are this one. Oops. Here. That we are right. And now it would be maybe, I won't show it now, but probably the persons in the domains, the domain experts that register a product or add a new address or remove that address or change the phone number will be always the same. It will be the customer or maybe someone from the same department. And these are the rules that must be enforced by the aggregate. This aggregate will have methods like add new address, where it's ensured that an address is not saved twice, maybe a method, a function that removes an address, and it makes sure that we always have at least one address, then maybe a method to change the phone number, where it's ensured that the phone number is correct. Here, again, value objects are our best friends. Instead of using strings or something like that, it's always nice to have maybe a value object that represents a phone number, and then the customer just needs to check that we have a phone number. We don't have to care if the phone number is formatted correctly or not. The same with an address. Then let's go to the next one. Here we have an order. And they are the same. But if I go and side by side, some of the facts, the events that happens inside. An order placed, order cancelled, order shipped, and delivery address changed. And here it's the same. When we place an order, that's at the beginning, that's perfect. And order cancelled, we have some business rules that are enforced by our aggregate root. Inside our aggregate is that an order can only be cancelled if it's in the status new or processing. Once it's shipped, then we can cancel this order. Then another one is something that happened when it's shipped, order shipped, and maybe delivery address changed. It's the same. Normally, I know this stuff is more complex, but for showing it, I hope this is good enough. Now, something that's interesting when we look at this orange post-its or boxes, these are events. And this is something that we also see in domain-driven design. They talk about domain events. That's something that happened inside our domain that is relevant. And this seems to be maybe relevant stuff for our domain experts. Is customer registered, customer added a new address. These are can also be called domain events, and those are published or created by our aggregate tool. And now let's go to the last one. Here we have the product, where we have new product added, product discounted, product review posted, and inventory count adjusted. I had here 2 rules. The only part that I'm looking at it and I'm not really quite happy is this review one. Is this review really part of the product, or can the review be an aggregate by its own? Maybe when we are then making this collaboration, modeling this stuff, we can see what are the actors or who triggers these functionalities or who uses these capabilities. And it's possible, it depends, that depending how it's used, maybe a review, it must not be part of the product. If we look at it, we don't see any constraints that the product have to ensure in the reviews, say at least one or a preview must always be in the feature. There aren't any business rules or constraints. This means it's possible that the review could also be an aggregate by itself. I will now in this example say, okay, let's do it, and say review is maybe also an aggregate. Now we have really small aggregates, and our business rules are still respected. Now, when we have something like that, happens something that I often see is that we have a UI and we have to serve the UI. And when we serve the UI, it's important to see how we can do that. And here it's important to differentiate what is the UI or the read models that are used and what is our domain model. And now to finish it a little bit, I will make it a little bit faster. I have something I will call it. That is where maybe projections are important. I'm running out of time, but there are the possibility to create a projection so that in the UI we have everything together. Maybe we have a read model, also called surface model, where everything comes together or put together and the UI can see it. And it's important to differentiate between the models that are our domain models, where the business logic lives, and the read models. Now let's get back to the presentation and take a look at our takeaways. I hope that one of the takeaways was that we focus on behaviors when designing aggregates. Then that domain models, that's what the last one, are not surface models. Domain models focuses on representing the business concept, rules, and logic. It's an internal view inside the bounded context, and surface model represents the external view of the system. And they're usually projection. We can have multiple models on the surface. Then that leverage the benefits of value objects. In my opinion, value objects are underestimated, and they help increase cohesion and expressiveness. Then effective aggregates are defined and shaped by their behavior, and use collaborative modeling techniques to design effective aggregates. Then iterate and evolve your domain models. They should not be static. Start small, iterate over your domain models and aggregates. Discover all the business rules and invariants. Discover also hotspots maybe, and fix them. And at least, last message from Eric Evans, effective domain modelers are knowledge crunchers. Models are never perfect, they evolve. Thanks.
Love that. Great job. Daniel. Great job very much. I especially like the fact that you did this exercise during the session, namely, how you split up the entities into different aggregates and how you added the constraints and all these things. So it was really informative. I like it pretty much. Yeah, it's a challenging topic, but I think you could really condense it and deliver it in a simple way. So great job. Yeah, we have a few questions. I would say let's go through them and let's see what is your take on them. First of all, we have this from Firefox. The question is, what is the relationship between the aggregate and the bounded context?
Okay, good one. Let me see if I will try to respond it. I hope I understood the question correctly. An aggregate will always live in a bounded context. There's something in domain-driven design that's the ubiquitous language. That's a language that is spoken inside a subdomain or a bounded context. And an aggregate lives always inside, and an aggregate will use always this ubiquitous language, the language that the domain experts speaks in the given domain. That's the relationship. You will never have a DDD aggregate the same aggregate that lives at the same time. That's difficult. You can have the same concept in different bounded contexts, but it's not let's say in the table, they are not directly linked or something. It's really something different. They live inside their own bounded context.
I think you showed also well in this presentation how you derived bounded context first and when you started working on your aggregates.
Mm-hmm. Exactly. That was one of the first things that I have done, because without bounded context, it's really difficult to shape good aggregates. It's difficult to see where are the boundaries.
All right. Thank you for answer. I think it was clear. So let's go on to the next one from Ologne. There are many concepts such as clean architecture, hexagonal architecture, onion architecture. Are there any relation between DDD and those?
Relation. You can use all of those when you are doing domain-driven design, but in order to do domain-driven design, you don't need any of them. There are also vertical slice from Jimmy Bogart. That will be probably the next talk, and it doesn't matter. I use hexagonal architecture a lot. That's the architecture that I use most, and it goes very well hand in hand with domain-driven design. But when Eric Evans wrote their blue book, the Bible, there was a layered architecture, and it also worked with a layered architecture. This means these are not really, you don't have to do any of this architecture in order to say I'm doing DDD.
Yeah, exactly. That's what you have, right? For example, hexagonal architecture, you have the application core, and inside the application core, you apply DDD, right?
Exactly.
All right. Let's see. We have here one remark from someone. Maybe you can give us your take on it. Me too, I love immutability. Maybe could you tell us why immutability is very important in the context of DDD, or why it really helps us to design better software?
I like immutability because today we have a lot of multi-threaded systems. In a multi-threaded system is safe. Once you have created this object, you can hand it over, you can hand it or move it around, and it will always be valid. There are no side effects. No one can change the thing that you are holding a reference on it. And I think there are a lot more. These are the ones that are going through my head in this moment, but that's one of the main reasons that I like immutability. You create it's correct, and then you know it will never change. You can just pass it around.
Exactly. All right. Let's jump to the next one, which is rather a remark, but here it is. Ninat, would be nice to see this implemented and a later session where new features are added and we see how the aggregates evolve. Thanks for the presentations.
Yes, this will be nice. Maybe it's possible. I think out there are a lot of implementations, but maybe maybe there's a possibility that I come back and maybe show how this can be implemented in C#. There are multiple ways how to do it, but maybe I can show one way how I will do it. And then you will maybe also see how I will use the hexagonal architecture to implement it. Or vertical slice. I tend to use both.
Awesome. Yeah, great remark. It seems like many people liked it. Another comment from the same person says, read the blue book, but not the red one. How much value does the red one add?
Whoa, that's something really subjective. I think both books are good to read it. The red one is not that hard, that difficult to read as the blue one, and is more verbose, has more examples as the the blue one. I think reading both, it's a good combination to have different perspective on the same topic. There's also a distilled one from Von Vernon. Domain-driven design distilled. This is also a good one if you want to have it really distilled.
Also, next to those, there is one, the Patterns, Principles, and Practices of Domain-Driven Design by Scott Millett and Nick Toon. I remember this was the first book I read. No, the first book I read, the blue one, and it was very theoretical for me, or it was mainly theoretic, right? So it's when I read the first book, it was really the Bible, and it's really a great read. But after that, I had issues with implementing it right away. So I decided, okay, let's read another book where I see more examples. And this one, what I mentioned from Nick Toon, is a very good one. But yeah, the red one also, I guess. Over there are examples, right, in the red one.
Yeah,
and that really makes it easy to adopt and to get started with. So yeah, great.
You just need a lot of time for the red one. Very, very tiny font size.
Okay.
But it's very comprehensive.
Cool. A lot of knowledge. So let's jump to the next one, which is from Victor. He says, really interesting, Alex. Please, can you tell us deeply about invariants as far as Aggregate is concerned?
I'm not sure if I understand the question. Maybe you guys can help me a little bit.
Sure.
So probably start with what is an invariant and how do you enforce invariants with aggregates? I mean, you can start from the very beginning, or
I will ever start. Invariance is something that always must be true. It always must be held inside an aggregate, and that's the invariant. And an aggregate will ensure that this will always be the case. That this is like. These are yet now not that good invariance examples because the example was not that complicated. But if I say you must always have 2 addresses, not 3, not 1, just 2. Now the aggregate ensures that every time you change something, or that you have always these 2 addresses and not 3, not 1. And there are a lot of stuff like this that are invariant, something that is must always be true.
I think this is a very good part, but this always has to be true and not just by creation.
Yeah,
there are a lot of people that has that's implementation. DDD book won't say how you have to implement stuff. You have to interpret it, play with it. A lot of people have validators, and for me, validators are cool. But if you forget to validate, then there is a risk that you have persisted something that is not valid. And I personally am not a fan of this kind of validation. I like to validate stuff in the moment that it happens or the modification is made.
Good point. And I think this question was answered. If not, Victor, let us know. But I think this is what he meant. Here we have one remark. Eric Norman functional programming book is a lovely read. I guess it relates also with DDD, or it has some bits. And here there is one from Wilcam. By the way, hey Wilcam, glad to have you as always. And he says the red one is far better than the blue one, more concrete. And yeah, more examples and more things to get started with domain-driven design. All right. We went through all the questions. Maybe I have a remark here about DDD, that I had a project back then, and I remember we wouldn't say struggled, but we had challenges with the aggregates. Like we had aggregate roots, and aggregate roots had another aggregate roots, which is not a load, but we really needed to add it, and also changing. We needed to update some entities in on entities part of the aggregate roots. I mean, so it's not allowed because aggregate root is entry put, etc. So it's there are a lot of rules how you design the aggregate roots, and we had much struggles. And somehow I had a thought that I mean, would DDD work without aggregate roots, or if you don't really follow these rules? Because DDD has a lot of good concepts. Of course, first of all, the strategic part, which is really takes it all, building the right thing, and after that we have the tactical parts, building the thing right. And but somehow we have these rich domains, and it has a lot of good concepts. So what is your take on this? I mean, can DDD really work without aggregate roots, or why it's so important to have aggregate roots, or what is your take on this?
I think it depends. I really like the concept of aggregate. If they are large, then we have this problem. I always playing a little bit around with them. One of the reasons is they say the aggregate root is the entry point to your aggregate, and you have to do everything up with your aggregate. And if you have a large aggregate, there's the risk that you have a code smell man in the middle. That says everything is put through the aggregate. And if you go in the other direction, then you have this train wreck or the train chain, or I have forgotten how the smell is called. And I think it's something that we have to balance a little bit. That's a Grund. Sorry, I'm mixing languages. That's one of the reasons I really like immutability, because today, at the moment when I design an aggregate, I do not create my value objects inside the aggregate because they're immutable and they ensure that on creation they are valid. I tend to do this in the adapters, really outside, because they're immutable. I have no risk that anything will be changed, and I tend to generate all the value objects. I have something that I call domain primitive. These are value objects with just one value, and I tend to create all this in the adapters outside. Once they are created, I pass them in, and now I have less new creations of objects. That's something that I'm experimenting around, and they are safe. I can give this. They outside the aggregate, they won't be changed. That's another reason for mutability, because if I give an entity, I hand it over outside the aggregate, there's a possibility that someone changes it, and now the aggregate can't not ensure that the invariants, falls there are, that the business rule are respected. And I think my experience is now that if I do that, I can avoid a lot of what you said, Daniel. I don't know if I really understand the problem, but I think this helps a lot. And then I tend to look, am I now changing, modifying? Then I do it through the aggregate route. Just tell don't ask, do this, and it does. But then when I'm reading, I tend to then ignore it a little bit and violate a little bit the law of the meter. But that is the trade-off. I'm always playing a little bit around.
True. Yeah, excellent. Yeah, it's a game of trade-offs. And also what I learned from that project, and it's that the domain continuously evolves, so we continuously need to change the things around. And yeah, it's great learning. Yeah, awesome. Thank you for this answer. We have one more, surely, or multiple. Yeah, people are getting excited. Let's do it. So here it is. More details about my previous question. Can another entity apart from aggregate controls invariants in a bounded context? Why, please?
Yeah, the aggregate root is an entity. That's the first one that will control invariants, and you can hand it over if you have an aggregate that you have the aggregate root, the first entity, then you have inside another entity, and he can ensure inside his boundary, inside the entity, ensure the invariance. Then it's meaningful that he does it. It does not make sense that the aggregate accesses it and modifies it from outside. It's again the same, always the tell don't ask principle. You can say the aggregate do something, and they can delegate it to the entity inside the aggregate. The important is from outside. It's for you like the aggregate root is making sure that the invariants are respected, but inside you can delegate it to another entity and it will make sure that the invariants are respected. I hope this helps.
Definitely. Thank you very much. Let's jump to the next one, which is a really good one. What do we need to consider while designing the database according to the domain model, especially given the situation why we want to re-engineer an existing system?
It would be interesting to know what kind of database we're talking about. Is it NoSQL or is it
let's start with we can wait for her answer, but let's start with the SQL. Right? That's basically the most known one, right? And after that we can talk about
SQL. Yeah, I think something that I tend to take care is to ensure that in code I have references from aggregate to another aggregate, but in the database I do not use foreign keys. That says the tables that I use to persist something has no foreign keys to another aggregate. This means I try to avoid that we can navigate through the entire database structures. The aggregate, as it's isolated in code, I do isolate it inside the database. That's something that I will consider. You can then always, if you have to do a projection, join something at some tables and make the projection as required. But I won't use foreign keys outside the aggregate. Just in memory will reference it. That's something that they will do. Then another thing that it's interesting is, I don't know what you will use, Anita, to persist. Which technology, EF Core or something other, something different is. Thank you. Now we have the answer. Is to use what EF Core names owned entity, to ensure that if you have let's see, we have an aggregate, we have a value object, I tend to persist it completely in the same table, not to just when we have a one-to-one relationship, just save it in the parent table. If we have a one-to-n relationship and it's a value object, value objects are always challenging. EF Core is now improving. They have something, I think it's called shadow property, that will handle this for you. But okay, I was reading the question. I think that's the most important, not to use too much foreign keys.
Mm-hmm. Great.
Maybe I'm now forgetting something, but
no, it was excellent. And also will come the fact to consider for an RDBMS database, no foreign keys between aggregates. So that's
exactly
the main
perfect.
takeaway. Awesome. I think we have still time for another question, and one surely, probably the last. So where do you validate the value objects if they are created outside of the aggregates?
On creation, there's a possibility to do it in the constructor or to create a factory method. And the factory method checks if the constraints are hold. And if it's so, then the object is created. Then here we have now something interesting. Maybe you are in a context where you say, okay, I would like to create money with a negative value, I would like to avoid this. And then you maybe throw an exception. This means your system breaks. Maybe you are now doing something afterwards where the user don't see it, and you would like to allow that calculations with money calculations are done. Then it's the possibility to use something that it's called, I think it's absorbing element. We have this is not a number, so that the system does not break. That you say, okay, if I multiply, I sum to money, and now I'm out of range, or it's in an invalid state, instead of throwing an exception, I will give back, or the result will be not the money. And the system can still work, and now I'm in an invalid state. That's something that's food for thought. Maybe you can use it, maybe not. Maybe it's desired to break, then just break.
Awesome. Thanks a lot. It's a great one, and the time is up. So unfortunately, it's time to wrap up. But I think we went through all the questions. So first of all, Alex, I would like to say huge thanks to your performance and that you've been here. We had a pleasure. and we had a very great session. We had a lot of people watching, so it means everyone were interested how to do that, and I think everyone took away some learning. So again, thanks a lot. And also I would like to say huge thanks to my co-organizers, Alina and Oliver, and of course thanks to the audience as well. And we were Tech Excellence, learn how to deliver quality software faster. And don't forget that you can find us on social media, and we have a great Discord group as well. So again, thank you everyone. It was fun, and see you next time. All the best.
Thank you.